All right, welcome. This is Unit 1, Lesson 1, Relations and Functions. So let's get started. A relation it's just a set of ordered pairs. There's an X and a Y, that's a pair. And lest we forget, the X is the input and the Y is considered the output. Now, let's come up with the 4 different ways that we can represent these, okay? We can have ordered pairs, which would mean 1, 3, that's a pair. A coordinate, rather. 4, 7, that's another coordinate. And let's say 2, -3, okay? So a relation can be represented by a set of some ordered pairs here, okay? And every one of these, of course, is an X and a Y, all right? We can map these, all right? Mapping, maybe some of you guys remember this. And we list all our X's here. We list all of our Y's here. Okay, so my X's will be 1, 2, and 4. These are all my X values. Okay, and all my Y values would be -3, 3, and 7. But not only do I list them, I've got to map. I got to show which X connects to which Y. So my 1 would go to 3, because that's my ordered pair, 1, 3. Okay? 4 would go to 7, because that's my ordered pair, 4 and 7. And 2 would go to -3, because that's this pair. In case you didn't realize, I'm representing each of the 4 different ways with these same coordinates that I have listed here. All right? So we can have ordered pairs, mapping, and then there's just the basic table of values. All right? Table of values. It's kind of like mapping, but you put it into a table. You don't need any arrows because they're all listed right across from each other. 1, 3, 4, 7, to -3, and so forth. That's the most common way we're used to doing it. And of course, we can always just graph these things. Now, I'm going to create a set of axes here. All right. And on our axes, let's not forget, on our axes, we need to go from our lowest one is 1 and our highest one is 4. So I'm going to make sure I have 0, 1, 2, 3, 4. And for our Y's, we go as low as -3 and as high as 7. So I'm going to include those values. -1, -2, here's -3. And then we have 1, 2, 3, 4, 5, 6. That will be 7. So all I'm going to do is just plot these points. I have 1, 3. Okay, go over to 1, up to 3. That's right here. That's 1, 3. Okay, I have 4, 7. I go 4 all the way up to 7 right here. That's 4, 7. And I have 2, -3, which is down here. All right? And that's graphing. So those are our 4 ways to represent relations right there. All right, so now let's apply this to a situation, a word problem. When skydivers jump out of an airplane, they experience free fall. With the coordinates listed below, the X value represents time in seconds, and the Y value represents the height in feet above the ground, okay? And you see we have all these coordinates here. We have them all listed here, 0, 10,000, 4, 9,744, etc. We have 5 coordinates listed here, okay? We're going to represent these in the other 3 ways, okay? Because obviously this right here this is a set of ordered pairs that's given to us, all right? So first of all, let's map these out. Now I have my X here, and it goes from, these are my X's, 0, 4, 8, 12, and 16. 0, 4, 8, 12, 16. And I have my Y's, which I'm going to make a little wider because I have bigger numbers here. 10,000, 9, 7, 4, 4, 8976, 7696, and 5904. Now, for this case, they haven't been written out exactly across from each other. But since this is mapping, we can't just assume that. We still need to draw our arrows. That is how we would have a mapping diagram of these sets of ordered pairs. All right? Next is a table of values. Now, that is pretty much exactly what we just did, except we don't need the arrows. 0 goes at 10,000. 4 would go at 9744, and so forth. I'm not going to finish that up. Okay, that's our table of values. Now, lastly, this other way, we have a graph. All right? Now, when I create my graph, I'm going to make sure I include my minimum and maximum values, meaning my low end and my high end for both my x and my y. So what do I mean? My x's go from 0 to 16. So I want to make sure I include those. Here's 0 on the x, 4, 8, 12, 16. All right? And I use increments of 4 because that's what they're given to me. Okay? Now, when I look at my y's, it goes as high as 10,000 and as low as 5904. So what I'm going to do is I'm just going to go from 0 to 10,000. And then I'll just go by thousands. 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 7,000, 8,000, 9,000, 10,000. And I'm just going to plot these points. Okay? The first one is 0, 10,000. So at 0 on the x, I'm at 10,000 on the y. The next one is 4, and that's almost 10,000. It's 9744. So 4, and that is real close to 10,000 right here. The next one is 8, 8976. So I go to 8, and I go to just about 9,000. And then right around there. At 12, 7696. So I go to 12. They go up to 7696, which is almost 8,000. Somewhere around there, give or take. And last is 16, 5904. So I go to 16, and I go up to almost 6,000. Right around there. So you'll see if I were to draw this, it kind of comes down like this. It starts at, there you go. That is those represent the other 3 methods of representing a relation other than the ordered pairs that were given to us. Now enters domain and range. Okay, first let's recall what domain and range actually are. The domain, well, those reference the x values. They are the inputs. Okay, they are also called the independent value. Okay, because it doesn't matter what anything else is to the x. It's independent of everything else. It can be whatever it wants to be. The range, on the other hand, the range are all the y values. Those are the outputs. Those are dependent values because y depends on what x is. You can't get an x out of your function. You can't solve your equation unless you have an x. Your y will change depending on what your x is. All right? All right. So let's take the domain and range of each of the following functions. All right? This is nice. It's just an ordered pair, this first one. Domains are all my x's. Okay, so my domain, I'm going to list this. I have 1, 2, -3, and 0. Okay, I could have listed those from smallest to largest, but those 4 elements are my 4 x values. What about my range? My range are all my y's. 2, 3. I already have 2 listed. I don't have to list it again. It's already listed there. And 5. That's my domain and range for number one. And of course, they gave me this over here to write it, and I should have. Let's see. Oh, look at me go. Domain. Bang. Range. All right, let's take a look at number two now. We do not have a set of ordered pairs. We just have a graph, and it's a parabola. All right? Well, let's look at the domain, which are my x values. So as this graph goes down forever, it also goes to the right forever. So it will go to positive infinity to the right. All right? And as I go down to the left, as I go downward, rather, it also goes to the left forever. So this is always going this way forever to the left. This is going to the right forever. So it covers from negative infinity to positive infinity on the x. It opens up forever. So domain from negative infinity to positive infinity. All right? Now, range is different. Range is my y values. My y values are what goes up and down, correct? The highest point on this parabola is the vertex, right there. Okay? And that happens when y is 1. Y doesn't get any larger than 1. But guess what? It goes down forever. It goes down forever. It goes to negative infinity. So what I like to say is, it goes from 1, let me do it the right way. It goes from negative infinity, because that's smaller, to 1. Now, anytime we have infinity, you'll see I'm doing this parenthesis or soft bracket, okay? When it comes to numbers, I either use a square bracket or a parenthesis. I'm going to use a square bracket because it includes the number 1. It can actually be the value number 1. If it did not include number 1, I would use a parenthesis, okay? So that's how I would write the range. And finally, we have this problem right here, problem number 3. This looks like a piecewise graph, which means it's parts of 2 or 3 different graphs all together. All right? And we still got to figure out the domain and range. Now, keep in mind, the domain is still the x value. I'm still concerned about going left and right, my domain, the x value. It looks like to me that this goes up and to the right forever. Excuse me, left. It goes up and to the left forever. So that will go to negative infinity. Okay? So my domain will go as far left as negative infinity. And we always use a parenthesis for infinity. Now, when we're looking at this graph and figuring out how far right it goes, all right? That's as far right as it goes. And for the sake of sanity, I'm going to tell you this is the point 2, 8 right here. And this is the point 6, 4 right there. Okay? So when x is 6, y is 4, right? Because 10 minus 6 is 4. Okay, that's how I came up with it. So this, x is 6. The y will be 4. Right? So how far right does it go? It goes to 6. Okay? So it goes from negative infinity all the way to 6. And it includes 6 because my dot is filled in. If that point would not have been filled in, then I would use a parenthesis. But since the dot is filled in, it includes the number 6. So I do the hard bracket or the square bracket. All right? Now my range. Okay, my range. That's the ups and the downs, right? The ups and the downs. It goes as low as 0. Okay? So it's going to be 0, and it's going to include 0 because it touches the origin. Right? And how high does this go? That goes to positive infinity. So positive infinity. And we always use parentheses to infinity. The range is your y-axis, up and down. right? So we talked about relations. We talked about domain and range, the natural progression. We talked about functions. They're equations, okay? They're equations, but there are certain criteria, all right, to make it a function. A relation where every input x has only one output, y, okay? Has only one output. You can't have more than one y value for each x, all right? And x should only have one y value, okay? That's the definition of a function. Now, the notation, we'd say f of x, okay? And again, you just heard me say it is pronounced f of x. Okay, here's a couple of examples here. We have f of x equals 2x minus 7. And the sine of x, that's trigonometry. Please, for everything holy, this is not multiplication. We are not taking f times x. That's a no-no. It's just notation. All right? And how can we tell if a graph is actually a function? How can we tell if we have a relation or some sort of visual on a graph and tell if that is actually a function? Well, we use the vertical line test. It's a test to see if a graph is a function. We draw a vertical line, and if it only touches the graph, not more than once, it can touch 0 times. It can't touch more than once. Then that graph is a function. Okay? So I pick any x value and I draw a vertical line. It's like you need to try to draw it. Okay? You need to try to touch it more than once with a vertical line. If you can do that, it's not a function. If it touches at most once at any spot, then it is a function. Okay? So let's just graph 3 things that are functions. That means these would pass our vertical line test. All right? So, all right, here you go. How about we start with something simple? We'll do a straight line. All right? Now that's my graph of x. All right? If I need to find if f of x is a function, I take a vertical line and I draw it. And it doesn't matter wherever I put that vertical line, I will not touch my graph, the black line, of f of x more than once. So that means f of x is a function. All right? And let's do another one. Here we'll do the ever popular parabola. There you go. That's g of x, let's call that. That should be a function because anytime I draw a vertical line, it doesn't matter where I draw this vertical line, I am touching that graph once. Okay. And last but not least, I think you guys are starting to get the picture. If I have something that goes like this, up, down, up, down, up, say, oh my God, that's h of x. Is that a function? Well, let's do the vertical line test. I draw a vertical line. Anywhere I put this vertical line, I am only touching my graph, which is the black line I drew, once. So h of x is a function. All right? Now let's focus on 3 relations. We're going to draw them on a graph that are not functions. That means they do not pass our vertical line test. Okay? Let's do this. All right, let's draw one here. Let's do a sideways parabola. All right? Now, if I draw a vertical line, and I say, oh, look, it doesn't touch. It touches 4 times. It's a function. You need to try to touch it twice. It's touching once there, but as soon as I go here, I am touching this at 2 spots, that same vertical line. So that is not a function. Okay? Let's do another one. All right. Good. If I have a graph that goes like this, down, like that, if I draw a straight line up and down, I mean, yeah, it touches once here, it touches the green line. It touches the green line once here, but if I move here, I touch it at 3 spots. That is definitely more than once. That is not a function. I saved the best for last. Let's say I have a graph here. And what I draw, I actually draw a vertical line. All right? Now, I take my vertical line, test. I say, okay, boom, I put it right on top of that. Does that touch once? Is that a function or is it not a function? And the answer would be, it is not a function. How come? Well, let me go here, y'all. A line is made up of points and coordinates. There's a coordinate. There's an infinite amount of coordinates and points here. There are so many that are squeezed together that they just look like a straight line. Every single point is on that line. So when I put my blue, okay, vertical line test on there, it touches every point on that line, all infinite amount of them. So yes, that's definitely touching more than once. That vertical line, my friends, is not a function.